Geographic Information Systems, GIS, are becoming one of the most important technology skills for future engineers. If you are thinking about engineering in college, technical school, or a career pathway, learning GIS now can give you a major advantage. GIS is much more than digital maps. It is a system for collecting, analyzing, visualizing, and sharing data connected to real-world locations. Engineers use GIS to solve problems involving transportation, energy, construction, water systems, environmental science, drones, and smart cities. Modern engineering is heavily connected to data. Civil engineers study traffic patterns and road design. Environmental engineers analyze flooding, pollution, and land use. Electrical engineers help design utility networks and renewable energy systems. Mechanical and aerospace engineers use geographic data for logistics, navigation, and drone operations. GIS allows engineers to see patterns that would be difficult to understand in spreadsheets alone. When location matters, GIS becomes incredibly powerful. Today, many GIS tools are web-based, which means students can use them directly in a browser without installing complicated software. Platforms like ArcGIS Online allow students to build interactive maps, collect field data, analyze information, and collaborate with classmates from almost any device. This makes GIS especially valuable in high school career and technical education (CTE) programs because students can quickly move from learning concepts to solving real problems. One powerful feature of modern web GIS is the ability to perform both vector and raster data analysis directly inside a web browser. Vector data includes things like roads, buildings, pipelines, and property boundaries represented as points, lines, and polygons. Raster data includes imagery and grid-based information such as elevation, temperature, rainfall, land cover, or drone imagery. Engineers can combine these data types to solve complex real-world problems without needing expensive desktop software. For example, a civil engineer designing a new highway could use raster elevation data and vector road layers in a browser to identify slopes that may create construction challenges or increase flooding risks. This kind of spatial analysis helps engineers make smarter, safer, and more cost-effective decisions before construction even begins. One exciting part of modern GIS is the ability to combine maps with storytelling. ArcGIS StoryMaps lets students create interactive reports that combine maps, photos, videos, charts, and written explanations into a professional-looking website. Engineers often need to explain complicated ideas to city leaders, business managers, or the public. StoryMaps help students practice that exact skill. For example, a student engineering team could create a story map showing the best location for a new bridge, analyzing traffic patterns, environmental impacts, construction costs, and nearby neighborhoods. Instead of turning in a simple paper report, students can build an interactive engineering presentation that feels like something used in industry today. GIS is also connected to many other technologies engineers use. Drones can capture aerial imagery that feeds directly into GIS maps. GPS devices help collect accurate field data. Sensors can measure temperature, water quality, traffic flow, or soil moisture and send information into GIS dashboards. Engineers increasingly work with real-time data systems, and GIS acts as the platform that ties many of those technologies together. Another growing engineering technology is the use of digital twins, which are virtual models of real-world systems connected to live geographic data. Engineers can combine GIS maps, drone imagery, sensors, and real-time information to monitor roads, buildings, utility systems, or even entire cities. A digital twin allows engineers to test ideas, predict problems, improve safety, and make better decisions before changes are made in the real world. Some high school engineering and STEM programs already recognize how important GIS has become. For example, Project Lead the Way, PLTW, includes GIS concepts within portions of its Engineering Foundations coursework and project-based learning experiences for high school CTE students. This helps students understand how engineering decisions are connected to geography, infrastructure, and spatial analysis. Students are not just learning theory, they are using technology tools similar to those used by professional engineers. GIS can also strengthen college and career readiness. Engineering programs increasingly value students who already understand data analysis, visualization, teamwork, and technical communication. A student who can create maps, analyze spatial data, and present findings through story maps may stand out during internships, scholarship applications, or job interviews. These are practical technical skills that connect directly to workforce needs. Another important advantage is that GIS works well with coding and computer science. Many engineers use programming languages like Python or JavaScript alongside GIS systems. Students interested in software engineering, robotics, drones, AI, or automation may find GIS especially useful because it provides real-world data for analysis and problem solving. Smart city systems, autonomous vehicles, logistics networks, and environmental monitoring all rely heavily on geographic data. Engineering careers over the next decade will likely involve even more spatial technology. As cities become smarter, infrastructure becomes more connected, and industries depend more on real time data. GIS skills will continue growing in importance. Students who learn GIS early may discover that they are not only becoming better engineers, but also better problem solvers and communicators. For high school students interested in engineering, GIS is not just about maps, it is about understanding how the world works, analyzing data in meaningful ways, and using technology to design better solutions for real people in real places.